Programmable Logic Controllers, Programming Basics. In this presentation, we're going to be looking at PLC programming languages, briefly, programming discrete inputs and outputs, and finally, Boolean logic operation. Now, most manufacturers have proprietary software that must be used to program their PLCs. Allen Bradley, Siemens, ABB are some of the more common brands available. Due to this, the user interface or visuals of the software and how the logic is entered will differ slightly from one manufacturer to the other. This presentation will provide visual examples which closely resemble Allen Bradley and Siemens PLC systems. There are a number of different PLC programming languages available to the average user: ladder logic, Boolean mnemonics, structured text, and function block. This is the method of inputting instructions into the PLC program. Ladder logic is by far the most common, and we will be focusing on this one for the duration of this presentation. But some of the others that are going to be used in different applications are Boolean mnemonics, structured text, function block. And function block is one that you'll see in some of the lower priced programmable relays because they're sort of using blocks that can be dragged and dropped into different locations in order to give an operation. So something you might see in the smaller end stuff. Now the process starts with a computer that has the proprietary PLC programming software downloaded. A blank programming screen is then populated with icons and symbols by drag and drop from the toolbar above. Inputs and outputs are laid out in similar fashion to schematic orientation. Inputs are always displayed on the left side of the ladder diagram, whereas outputs are displayed on the right side of the ladder diagram. So there we have input and we have output. Inputs and outputs are shaped differently and identified with a different letter. So depending on the program used and the brand, the letters and the shapes of the symbols may differ slightly. So on this particular system we can see here, often on different PLC programming languages you'll have an I or a DI or a Y or an S, and for outputs you'll have an O or a DO or sometimes Q. So it really does depend on the manufacturer. Each individual input and output is uniquely addressed with a number. The number is based on the physical termination on the PLC card. So this one says output 1, and on the left it says input 6. So there's my output card. This output would correlate to this screw on the termination of that output card. Looks like it's a green wire. Now, ladder operation is important to understand. The operation of the output depends on the condition of each input on the same rung. The condition of an input is said to be true or false. Inputs which are true will change visually in the PLC program. And so you'll see that in a number of different ways. It might be with just a red box, or maybe it's going to be overlapped with a sort of a transparent yellow, or maybe the lines on either side will light up. It really does depend on the program that you're using. So here's an example of a basic PLC discrete operation. I have input 6, which is a discrete input, and I have output 1, which is a discrete output. When input 6 goes true, it then allows for a full unimpeded path of logic to allow for output 1 to go on. And that would then allow the PLC to energize output 1 and the small load that is connected to it. Now, PLC discrete inputs and outputs can be multiplied as many times as are required through a program. So we can see here input 6 is duplicated a whole bunch of times, And output 4 is duplicated a couple of times here and here. So you have unending options of how many times you wish to use an input inside a PLC program. Now there are two different types of PLC discrete inputs. They're known as examine if closed, sometimes abbreviated as XIC, and examine if open, often abbreviated as XIO. Examine if closed means closed as in there's a 1 or a high signal received at the input terminal of the PLC. When the signal 1 is present, the PLC will consider the instruction true and then examine what action is required to be executed. So that's where the examine if comes in. So that means that this input instruction would be false if there is a low or 0 signal present at that terminal. The input in the program acts as an open contact. Here, true, this would mean that there is a high or a 1 signal present and the input in the program acts as a closed contact. So this gets a little bit confusing when we start making references to open and closed contacts. This is not an open or closed contact. It is an examine if closed, and it can be in false or a true condition. Most input instructions for discrete input are examine if closed. Examine if open is a little bit different. Open means there's a 0 or a low signal at the input terminal of the PLC. When the signal 0 is present, the PLC will consider the instruction true, then examine what action is required to be executed. So again, here we have false and true. So this is my XIO. There is a high or a 1 signal present. The input in the program acts as an open contact. It will not pass logic to allow output 1 to energize. Here we can see it's true. There is a low or 0 signal present. The input in the program acts as a closed contact. So let's see what this looks like. Power is off. I have input 0 and input 2. This is a normally closed push button and a normally open. The normally closed push button, input 0, is connected to or programmed to both an XIC and an XIO discrete input symbol. Same with these two down here, they are programmed back to I2. Power is off, so let's turn the power on and see what happens. Immediately, we can see here a normally closed device is applying a voltage to input 0. With the XIC device, that results in this input programmed symbol going true. The XIO remains false. So false when there is voltage applied to input 0. If we go down to this one, this is a normally open push button, so there is no voltage being applied to input 2. That means the XIC remains false, but the XIO is true. So remember, XIO goes true when there is no voltage applied to the input terminal. An interesting application. All right, so let's go through a full example of how this would function. We've got a PLC with one normally closed push button connected into discrete input 1. And then we have two different discrete outputs, a red and a green light. And they are outputs. Now what we're going to do is we're going to show that the input signal on the push button is on or 1 or high, and then we're going to take a look at the program. So here's the program for the PLC. Input 1, because I only have one input, is both, we have an XIO and an XIC. So two outputs, output 1, output 2. So right now, we should see that this top discrete input symbol is false, and that's because there is voltage being applied to terminal 1 right now by the normally closed push button, and the output 1 is then off, and that's because this is false. If we take a look at the next rung down, this is true, and the output should be on. And it's true because voltage is being applied to input 1. If we then take our finger and push that down, things change. Now, there is no voltage, or a signal of 0 being applied to input 1. That means that input 1 here, this, should go true, and output 1 should be on. When we look at input 1 down here in the program, that should be false, and that would then remain output 2 being off. So I hope this has helped in a basic understanding of how the programming and operation of Boolean logic and discrete input and output would work in a standard PLC program.